Good evening, everyone. I'm sending you all warm greetings on the behalf of Bosnia and Herzegovina Futures Foundation. Let me first introduce myself. My name is Emina Mahmudbegovic, and I'm a final year student at the Faculty of Electrical Engineering in Tuzla. I'm also a coordinator of the Futures webinar series. It is my honor to host a webinar tonight because our guest, Dzevad Trumic, worked for 15 years at Google as a site reliability engineer. Since April 2018, he works as a head of site reliability engineering at Goldman Sachs, one of the world's largest investment banks. Dzevad, welcome to the Futures webinar series, and thank you so much for accepting our invitation and giving this presentation to our students and young professionals. You are a true role model and an inspiration to all of us.
Thank you very much, Amina. Thank you, everybody, for joining. I'm delighted to be here and to support this foundation. I've been talking with Eddie and some other participants. It's a great thing that you're doing, and I'm happy to spend some time with everybody. I would like to make this as interactive as possible, so feel free to ask questions. Amina will then relay them to me during the presentation, and we can just make this a bit more interactive. All right, so let's start with what SRE is. In short, the founder of SRE would phrase it as software engineers solving operational problems. As we'll talk about later, SRE is a discipline that was founded at Google in 2003, and the founder of SRE at Google, Benjamin Traynor-Sloss, basically wanted to take a software engineering approach and apply that to solving operational problems in production. So why did he want to do that? So it turns out that software engineers have some qualities that are really lend themselves really well to running production and systems at scale. Software engineers can code, and they're lazy. They get really bored, and it's really important to get both of these qualities in, because it's not obviously sufficient to just be lazy. You also need to be able to automate yourself out of a job. So you take these two qualities, you put them together, and you create a team around that. What you end up with is a ton of automation, and essentially SRE's purpose is to automate themselves out of a job every 18 months, which means we are in the business of attacking new problems. We're in the business of really digging in and finding what's wrong in existing software systems so that we can focus on the future. Let's talk about what SRE isn't, first of all. So SRE is not a glorified operations team. So what do you mean by an operations team? A traditional operations team would consist of system administrators, for example. These are people that are very good at individual systems. They're very good at knowing, for example, how a SQL database fits onto a Linux computer, and they really understand that package. So SRE is not just a better set of system administrators. SRE looks at things on a large scale, and SRE tries to solve problems through software, which we're going to get into throughout this presentation. SRE is also not a team that just follows directions in runbooks. For people who are not familiar with what runbooks are, these are essentially written steps of what to do when something goes wrong. So if you've ever called desk support for something you had, a product you have, or a piece of software you have, generally the help desk you call is just some folks who go through a list of pre-written steps that were put together for them by an engineering team. So an SRE team does not do runbooks. An SRE team is also not a NOC. For people not familiar with that term, a NOC is a network operations center. And there's generally folks who sit in front of giant screens, and they just look at graphs on that screen. and they try to figure out when something goes wrong because they noticed that there's a red light in on one screen, or they notice that some other screen shows them something else. So SRE does not do that because again, we employ software to do things. We do not rely on humans to observe anything, and humans are generally not very good at doing that, and they're very, very slow. So why do we need SRE? We argue that reliability is the most important feature. If you have a service, if you have a website, if you have an app, it doesn't matter what kind of service it is. If it doesn't work, all the other features are irrelevant. You can have the latest bells and whistles on your service, on your app. If a user cannot reach it, that doesn't matter. Right? So reliability is first and foremost, especially this day and age. People are very impatient. People are used to everything loading pretty much immediately. If your app or your website were to hang for 10, 20 seconds, people are just going to leave and go somewhere else. Further, complex systems break in complex ways. As people start out in computer science, they start building relatively simple programs that they can understand. You start with something that has a couple hundred lines of code. You wrote the code. You wrote some tests for it. You really understand. How that works, and you run it generally on one computer, and then you kind of understand that package. Complex systems rely on multiple such pieces of software, all of which perhaps run on multiple machines themselves, any of which machines can fail at any one time, and then those systems need to interact with other systems. So when that thing breaks, it is generally very difficult to understand why it broke. Reliability tends to get overlooked until something goes wrong. And so people get into this reactive mode of something broke, and therefore I need to now go and figure out what went wrong. And because the systems are complex, because they're large, and because people don't work on reliability all the time, they generally find themselves in a situation where more than one thing has broken. So now they're in this reactive mode where they need to fix everything that broke within that system, and that reactive mode will, of course, slow you down significantly to be able to get your system back. And while you're slowed down, you now cannot release features for your software. So that slowdown is really detrimental. In addition to that, any kind of downtime, any kind of significant downtime, this day and age is considered really bad. Lots of applications you're used to using, if they stopped working for an extended period of time, you would just go and use something else. So SRE arose for multiple reasons, but one very fundamental reason, and that is this notion of developers, and I put versus in quotes here because it really doesn't have to be versus, but generally is, traditionally has been developers versus operations people. So on the one hand, you have developers who want to launch a bunch of features. This is how they get paid. This is how they get compensated. This is how they get rewarded. They wake up every day wanting to launch a bunch of features. On the other side, you have operations people, again, traditionally sysadmin type folks, who want to avoid outages from happening. And they specifically want to avoid outages on their shift because sometimes it's late, they don't want to be woken up. So you get this natural conflict that arises between the groups who want to push change and groups who do not want to push change. And because these groups traditionally have been isolated and siloed, SRE attempts to remove those silos, and we'll go into how exactly we do that. But this conflict arises, and this conflict has traditionally not been solved in an objective way. So this is what generally people have tried to do before. So they end up creating an exhaustive launch review. So you get together in a large room full of people, and you go through a launch review. Did you do X? Did you do Y? Did you do this? Did you do that? That generally turns into a kind of checklist type environment where you go through an exhaustive list of checklists, an exhaustive checklist of everything that has ever gone wrong in any system, right? Because that checklist will just keep growing and growing and growing. Now, that checklist then becomes problematic to deal with because of just the sheer complexity. Perhaps something that happened to a system is completely irrelevant to this system. Then the checklist itself becomes a burden, becomes a process to launch anything, and that slows you down. And we live in a world where you need to continue launching new features because that's how you progress your business. So we need to be as agile as we can be while still being safe. A thing that also doesn't work is asking humans to be more careful next time. We see this all across the industry. Mistake happened. Jane was on call. She did something she shouldn't have done. Now we're going to ask Jane and everybody else to be a bit more careful, right? This simply doesn't work. Like we need to come to terms with the fact that humans are just not reliable. They're not nearly as reliable as we need them to be. So relying on humans is just doomed to fail. So the SRE solution to this is something we call SLOs, or service level objectives. What we attempt to do with SLOs is to mathematically express the happiness of a user. An example of that is if you would like to do a web search, for example, this day and age, if google.com or bing.com or your favorite search engine does not load roughly within 1 second, you're already getting annoyed. If you then type in a search result and the search results take, let's say, 5 seconds, maybe 10 seconds, you probably around the 10-second mark, you're going to leave one search engine for another, right? So user happiness can be measured. You can experiment with it. You can find where the sweet spots are. You can find where a user gets annoyed with either the speed of at which pages load, or they get annoyed with the quality of the content. Whatever it might be, there's a point in time where people get annoyed with your product, and there's a point in time where people experience, basically it's painful for them to use your product. It's at the painful part. It's at the painful stage when people go and use a competitor, and this is when you lose users. So it's very important, for any app that you have, any service that you have, to really understand your users, to understand what makes them happy about using your product, and especially to understand what makes them unhappy. We'll go into this a bit more in some later slides. From SLOs, we derive something we call error budgets. And we'll talk about that in a later slide as well, but it's a very easy way for us to understand whether we want to focus on feature releases or whether we want to focus on reliability. What we want to do is measure early and often. Everything in SRE is measured down to the most lowest level of detail. We like to understand our entire stack, we like to understand our users, we like to understand everything we can about our machines, systems, etc., so that we can really reason about the systems. When you have an SLO-driven organization, the system is self-regulating. You basically get to a point where you are handed a budget of outage, which we call an error budget, and you make your engineering decisions based on that budget. We'll cover budgets in a later slide in slightly more detail. But first, let's talk about the distinguishing features of SRE, because people might be asking themselves, how does SRE differ from some other things that I'm used to? So we generally hire people who can code. So we don't hire exclusively software engineers, but we hire people who are able to code beyond simple scripts, because we're trying to build distributed systems. We're trying to build complicated systems. So just simple scripts here and there will not suffice. We do require people have at least some basic understanding of algorithms, computer science, kind of the general notion of complexity, how software runs, etc. SREs rely on SLOs and error budgets for data-driven decision making. We cap our operational load, and we emphasize the engineering in SRE. So what is, we'll cover operational load in a later slide. We'll cover operational load in a later slide, sorry. We then allow only 2 events per on-call shift in SRE. The reason we do that is SRE is generally in what we call the novel outage business. Because we have a rigorous post-mortem process, which is last on the slide here, when an outage happens, we go in and we dig in very deep, and we understand exactly how our systems fail, and we fix everything that we found during that review process. That means we have already, by definition, fixed all the known problems that we have. That then means everything we see, every new problem we see, is something we've never seen before. Because of that, we need to cap the number of events that we're allowed during an on-call shift, because we've never seen something. We need time to investigate that. So SREs are generally on call for 12 hours a day, roughly 2 or 3 times a quarter for about a week. During that time, we do not allow SREs to be paged more than 2 times, approximately. We have a minimum on-call rotation size of either a single location of 8 people, or we have 2 geolocations roughly 8 hours apart with 6 people each, which means for most SRE services, you would expect to see a group of around 12 to 15 people, and they have a 24/7 on-call coverage. And as mentioned before, we have a rigorous post-mortem process. For people not familiar with the term post-mortem, post-mortem is something that it's a document that we write after an outage has happened, and we dig into all the different details. We extract timelines, we find the root causes, we find exactly what went wrong, and then we create action items from that document, and then we focus on fixing those action items, which means the thing that happened in that particular incident will not happen again. I will pause here briefly, just in case people have some questions, although, again, feel free to interrupt.
So yes, only I have one question. So is SLO-driven organization some sort of a closed loop system, like in control systems?
Yeah, that's exactly right. Okay. So when we said the system is self-regulating, that's kind of what we mean. I'll cover that in a bit more detail in a following slide on SLOs. Okay,
thank you. So we don't have any more questions yet.
Excellent. I'm 100% clear in everything that I'm saying. Okay, so operational load. Operational load is anything basically that's not engineering. So being on call, doing some troubleshooting, doing some manual rollouts, doing something we call toil, which is really the worst kind of manual work. It is manual work that doesn't have any long-term benefits, stuff that should really be automated, no human should ever have to do. We put a cap on the operational load in SRE at 50%, which means SRE is primarily an engineering organization. We do on-call and these other operational things simply because you have to be on call for a service that you own in order for you to understand that service. But SRE's primary purpose is engineering. Therefore, if we do not cap the amount of non-engineering that we do, we can't effectively call ourselves an engineering organization, and therefore that is capped. All the additional operational work falls onto the development team. So generally, you would have a product that has a development team that vastly outnumbers the number of SREs, sometimes between 6 and 10 developers for every one SRE. The reason for that is very straightforward. Any business, any service, website succeeds because of usage, and usage gets increased by launching features. This is where developers come in. So a product team is generally formed of developers and formed of SREs. Developers wake up every day wanting to launch features. SREs wake up every day wanting to maintain reliable systems, but these are just focus areas. Of course, a developer cares about the reliability of their system as well, and of course, an SRE cares about features as well. But again, the primary focus for these groups is, on the one hand, you have features, on the other hand, you have reliability. And these two things are generally in conflict. The faster you go, the more change you introduce into production, the more it will break. That is just a truism of running systems. And so these things are generally in conflict. Hiring. So we are looking for software engineers and system engineers and hybrids thereof. So software engineer is, I think, probably very clear to people here. Computer science background, generally deep understanding of algorithms, generally, very strong in at least one serious language. So, not something like, shell scripting or anything like that. Like real understanding of let's say Java, C, something like that. But it doesn't actually matter as long as they have really strong computer science backgrounds, because the theory in computer science is really what drives the design of systems, and having a fundamental understanding of how that works is critical. Then we have systems engineers, and the way that we describe systems engineers is by first describing what a system administrator is and then saying that it's not that. So a traditional system administrator is an expert in taking some software artifacts and joining them on a machine. As I mentioned earlier, let's say you have a SQL database on some Linux machine. Traditional sysadmins really understand that package. That is not really the type of people the type of talent that we're after. Although we do hire very, very strong sysadmins, for systems engineers, we're looking for people who can we're basically looking for people who can build a distributed system, right? So if you think of a block diagram that you could draw on a whiteboard, you would have, system A talking to system B, and then, maybe to system C that all relies on system D. And when you sketch all of that out, you can build a pretty complicated system. This day and age, some of these block diagrams can actually be cloud products, right? So behind every one of those blocks that a system engineer would perhaps put together, you might have a development team measured in dozens of engineers. And so the power comes from taking some of these disparate systems, arranging them into a larger scale system in such a way that that's reliable and it meets the business requirements. The hybrids that we hire between these two is basically people who are very close to the software engineering ladder, but they're not quite a software engineer. So what we do in those cases, if you do not have sufficient depth in either software engineering or systems engineering, you can offset some of that depth with breadth in both. So if you have someone who's almost a software engineer, if they then on top of that bring some depth in Unix, in networking, and general systems, that combo together, that hybrid combo, we've seen work very, very well for us. SRE does not hire pure architects, and our definition of architects are people who can just sketch out something, but then they don't participate in the implementation of that system. So we do not hire architects. We expect everyone in SRE to be able to implement everything that they design. So everyone in SRE is hands-on. Also includes managers from time to time. When orgs grow, management becomes kind of a full-time job, but certainly in smaller organizations, you would expect managers as well to be technical and hands-on. So SLOs and error budgets. When we want to construct an SLO, we first start with something called a service level indicator, or an SLI. Think of an SLI as a representative metric for a service, right? Something like request latency, error rate, bandwidth, things like that. The litmus test here is that graph moves when something interesting happens in your service. And it is strictly correlated, which means if it moves, something interesting has happened. And if something interesting has happened, you would expect that graph to move. Again, this all depends on your system. We do not have enough time to dig into the depth, into some depth on SLOs, but think of it as some representative metric. Then we take that representative metric and we put some bounds around that. So for example, average latency less than or equal to 200 milliseconds, 10% of the time, right? Mm-hmm. And that is something we call an SLO or a service level objective. So this n% of the time would generally be something like 99.99% of the time. So when we say services run at 3 nines, 4 nines, 5 nines uptime, this is actually what we mean when you dig in a bit more detail, because you really need to define what availability is. If you have a search engine, right, the thing you actually want out of search engine is search results. That's the thing you want. If you are trying to access a bank online, the thing you actually want is to transact with the bank, right? Therefore, it is insufficient for you to just be able to go to the bank's website or to the search engine's website. Simply displaying the website is not why you're there. You're there to perform an action. It is that action that needs to be measured, and it is those nines that we actually care about. If, for example, you can access your bank's website, if you can log in, you can see your statements, you can see all of that, but you cannot move money from your account, you're not going to be happy because it's your money, you should be able to move it. That thing needs to be measured. SLAs, or service level agreements, are basically SLOs with monetary consequence. This is not something that SREs generally need to care about. This is mostly for legal documents and lawyers. And so we'll just skip over this for now. SLOs is really the most important part. And you have error budgets, which is basically one minus your SLO. So you have something like 99.99% of time you want a certain thing to happen. That means the budget you get for the year, or if you want to chunk it up into monthly or quarterly cycles, is 1 minus 99.99%. That means that is your allotted budget to push some software releases that maybe are a bit risky, go a bit faster on launching some features, et cetera, et cetera. Again, remember, every time you introduce change into production, you should expect production to break more. Therefore, and this is really where the self-regulating system comes in from Amina's question earlier, this is what regulates the system. If you have error budget, the development team is free to launch more features. If they do not have error budgets, then we collectively focus on reliability. This is where the self-regulation comes from. I will pause here briefly as well, just in case there are some questions. And sorry that I'm talking fast. I would just like to cover a bunch of this material in the 45 minutes that we have.
No, we don't have any more questions yet. I'm sorry.
All right.
Everything's clear.
Crystal clear.
Yeah.
Excellent. All right. So onto the fun part of math. So generally, SRE doesn't have a lot of complicated math. It's mostly, adding numbers and sometimes doing some division. It's simple stuff, but it's very important to understand. So we can define availability in a couple of ways. One way is you take, you start from a binary point of view that your system is either up or down according to some definition of uptime and downtime. Right? So the total time spent is your uptime plus your downtime. The uptime that you have divided by the total time, that can be considered availability. Similarly, we have these concepts called MTTF and MTTR. MTTF is the mean time to failure. That is, on average, how frequently will your system fail? And mean time to recover is, on average, how long will it take you to bring your system back once it has failed? So these are a couple of ways to define availability. By simple measurement there, one complete 30-minute outage per year gives you roughly 99.994% overall availability. By this, again, simple formula below, which is just using the mean time to failure formula. Right? Which means something like, Google.com or some high availability websites that are roughly 5 nines availability, they basically have something like a maximum of 5 minutes of outage per year. Now we'll go into that a bit more in the following slide, but let me cover something else first. So ways for you to increase high availability, right? Because we're dealing with a ratio of a denominator and a denominator, we can just tune those numbers, right? So you want more availability, how about you increase your mean time to failure, right? So if you have less frequent outages, and that can be accomplished by a better rollout policy, by better testing, various other things, then you can, from an engineering point of view, increase your availability, where you can have confidence that you've done that. You can also, and this is from my point earlier, reduce the blast radius, right? So something like, again, pick a website that's, or service that's highly available, they're operating probably in somewhere in the neighborhood of 4 or 5 nines, right? Which means for 5 nines, you're basically looking at 5 minutes of outage per year, and then it's order of magnitude from there, right? So a 4 9 system would be roughly 50 minutes a year, etc. The thing that a bunch of serious and scalable services focus on is this thing called blast radius. That means even when you do have an outage, you don't want a global outage, right? So you take like a mail client or maybe Facebook or something like that. If you must have an outage, how about you have an outage for just a subset of your users and not all of your users? When you do that, then you should only be burning one portion of your error budget and not your entire error budget. And because you have isolated outages, again, engineered into the system, not random, when you do that, then you're not going to end up on the front page of a newspaper when your service goes out, because it's not going to impact all of your customers. That is something that needs to be engineered. You cannot stumble your way into this type of system, because generally people build global systems and global systems fail globally. Another thing you can do is reduce your MTTR, right? So if something breaks, if you can undo the breakage very, very quickly, then you can reduce your mean time to repair. And when you do that, you increase your overall availability. One thing you cannot rely on for high availability systems is for humans to do the right thing. There simply isn't enough time. For something like 5 nines, you're looking at overall downtime of 5 minutes. Human reaction time, even if you're directly on the computer, is going to be half a minute, maybe 1 minute, and then they need to debug the problem and fix everything. That cannot happen. And even if you got super lucky and you made that happen once in 5 minutes, that means you can now not have any other outages for the remainder of that year, right? That is just not something that is feasible. Right. So one thing that we have in SRE is that outages will happen. We specifically do not design 100% available systems. 100% available systems are generally indistinguishable from systems that are available 5 nines of the time. That is going to be the case with most things you are familiar with. Your mobile phone is not 5 nines. Your Wi-Fi at home is not 5 nines. Your internet connection is not 5 nines. Your cell tower signal is not going to be 5 nines. Your computer is not going to be 5 nines, et cetera, et cetera. And so when the service you're trying to access is also not 100% available, then you simply cannot tell. And therefore, we just don't build systems that are more reliable than we need to, for the very simple reason that the more reliability you want, the more costly it gets. Something like 100%, even if we could do it, and we probably cannot, would be prohibitively expensive. That means you would need to have roughly infinite revenue for your service to be able to justify that cost. No service has infinite revenue, and therefore it is just not feasible to do that. So we do not ever focus on 100% availability in SRE. We also claim that approximately no system exists with 100% availability. And as I mentioned earlier, SRE is in the novel outage business. which means everything we see we've never seen before. That means engineering needs to have already happened for these systems. One question that arises often is, if you're on call and you have a 5-9 service and you only have 5 minutes of downtime per year, then why are you on call? Doesn't that mean your people don't have enough time to react, etc.? So that is true to a certain extent, but there are a couple of things in here. First, we have something that we call simple hammers that we have already built into the system, which means it's very easy for a well-designed system for you to just say, stop using this data center, or this cluster over here, or this set of machines. That is something you can do very, very quickly as an on-call person, and it will simply stop that entire thing from being used. It'll stop the bleeding immediately, which means your outage stops immediately. When you take that to the next level, you have a system that auto-heals, which means it fixes itself for the known issues. Okay, I think we should move on to the next slides on this. I think I've talked enough about outages. Okay, so we need to come to terms with the fact that outages will happen, and we really need to understand that they will happen despite humans' best efforts. It is extremely important not to blame humans. The way we view it in SRE is that outages happen despite the human's best efforts. The human had all the information available to them. They had the best intentions. They did the best that they could. The system failed anyway. That allows us to be extremely critical of systems and not of humans. Now, do human errors happen? They happen all the time. But we do not blame people for that. We ask ourselves, why did that human make that mistake? Humans will make mistakes. Maybe the human doesn't need to be in that process at all. So maybe we should remove the human from the process completely. And that allows people to work in a culture that is open, to work in a culture where failure is acceptable, and to work in a culture that does not put an extreme amount of pressure. It is a well-known scientific fact that humans do not work well under pressure, and certainly not for extended periods of time. Even those of us who do a bit better under pressure, after a certain amount of time, we will just simply burn out, and that is not something you want for your engineers. A blameless culture becomes extremely, extremely important here. We specifically do not rely on human heroics when building systems. You cannot build a system and then expect the right person with exactly the right knowledge to be at the right time and to execute exactly the right commands to bring the system back into service. Therefore, the engineering needs to happen beforehand. One thing I like to say to people a lot when I try to explain to them SRE is that generally engineering is proactive and operations is reactive. And so as an engineering org, we have to focus on the proactive engineering, and therefore we cannot rely on the right things being in place when our inevitable outage happens. And finally, on to SRE and DevOps. DevOps is a very popular term. People confuse it, these things a lot. I just want to clarify something, and this is something that I have kindly taken from my ex-colleagues at Google. Basically, if you look at the history, SRE came about in 2003 at Google internally. It wasn't really talked about a lot until only a few years ago when we started publishing SRE books, putting on SRE conferences, etc. DevOps is a term that came about roughly in 2008, and some people, people view it differently, but generally the DevOps tenets would probably be the following 5 in some kind of configuration, right? Failure will happen. Reduce organizational silos. The thing I talked about earlier of having a development team on one side and an operations team on another side, those are siloed organizations, right? So cut through those silos. Gradual change, right? Push often and push things that you understand. right? So if you have a small change, you can understand that. If you gradually release that, that means you will break only a subset of your system. And when you do that, when you roll back, going back to our error budget discussion, that means you only consume a fraction of your overall error budget, and allows you to break a part of your system, not the entirety of your system. Good tooling and automation, and finally measure everything. All right. So if you look at the DevOps tenets, you can view SRE basically as a very prescriptive way to do DevOps. Right. So in computer science terms, and I guess OO programming sense, in a OO programming sense, class SRE implements interface DevOps. Right. So SRE and DevOps are not in conflict. And people will generally, spend their time better trying to understand either of these things in more detail than kind of debate the difference between SRE and DevOps. And with that, I would like to thank everybody, and I would like to take a few more minutes to answer any questions you have, either on this talk or anything else.
So I would like, firstly, thank you for giving us this presentation. And yes, we have 3 questions more. First question comes from Kenan Kurdic from Sarajevo. Is it possible to land an entry-level SRE job, or is it better to sail into SRE later on after collecting some DevOps, software engineering, practical knowledge and experience?
DevOps, like I said, DevOps is not in conflict with SRE. SRE hires software engineers. SRE hires a ton of graduates. It is absolutely fine to join SRE. In fact, we encourage it. The thing that we need to keep in mind is that SRE as a discipline is something that needs to be learned. Therefore, it is infeasible to bootstrap SRE without having other SREs present. But if you have a mature organization with a bunch of SREs, it is absolutely possible to join, and I would encourage you to do that.
Thank you. Another question comes from our chair, Edhem Chustovic. He firstly thanks you for giving this presentation as well. He said he had the pleasure of meeting Benjamin Traynor-Sloss, your former boss and founder of SRE at Google. They had a chat about which was focused on Google's brand power and reputation, that other companies were almost blindly adopting Google's SRE models. What is your opinion on this, and how closely should other companies follow? Can you comment pros and cons?
Yes, I mean, I'm obviously I'm very biased. It's the world I've lived for a decade at Google. I did some other stuff at Google as well. I came to Goldman Sachs to basically do roughly what we did at Google in a very different environment. So I'm a huge proponent of that. It is not the only way. As far as I know, it is the most peer-reviewed and the most in-depth and the most formalized way to do DevOps. I'm not familiar with other ways that have the same level of rigor applied to it. And something like Google SRE is the largest SRE organization in the world, obviously, and the largest any such organization. The amount of R&D that they were able to put into this will probably surpass anything else. So of course, I'm very supportive of that.
Thank you. And we have just one more question left. Okay, from Kenan Hrnic. What about AWS's S3 durable storage with 9 or 9S? That's the question.
Yes, so durability is a different thing. Durability is not availability. Durability just means do not lose the bytes that I store on disk. It is absolutely possible to have 9 or even more 9s and S3, Google Cloud Storage, Azure, storage, like all those companies are able to do that. And you can do that by simply replicating. I mean, I say simply, it is not simple at all. Storage is one of the most difficult things to do, but effectively you just replicate it so often in so many places that it is so unlikely for all of them to fail at the same time, and you can certainly get durability. what you should be aware of is you might not be able, like you will almost certainly not be able to retrieve those bytes at nine nines, right? But they will be there, they will not be lost. And that is the trade-off that you really want for something like storage, right? Even if you cannot access it, at least don't lose my data, right? So that's a durability SLO that cloud storage providers are offering.
Thank you. So that's it. I would like to say good evening, good night to all of you. And this has been an interesting presentation. And I think that some of us even want to work as an SRE, as SRE engineers now. So good night.
Thank you very much. Thank you, everybody.